Okay, so where we left off was back here a couple slides ago talking about text file input and output. So I'm just recovering this. So the standard ones that they did back, several years ago when they wrote this textbook were file reader and buffered reader. You can also use scanner classes, but the one that you might use nowadays is this BufferedWriter class. And it basically works the same way. Again, you embed your code in a try-catch block. You build the water slide, so you might have a file writer object to send it to some file that you've created, and then you affiliate the buffered writer object with your file writer, and then you push in some data to your buffered writer, and there it goes. It basically works the same way for doing buffered reader to retrieve object from a file, and you create a file reader object that you connect to your file. So same kind of structure, works the same kind of way. The difference is it's a bit more efficient for handling large data strings. But what we're interested in today primarily is objects and saving objects to files. So we're going to do a new class for that. Let's bring it up. We're going to go call it Fun with Files 2. And it's going to feel a lot like our previous one.
Professor?
Import Java.io.
Hello, Professor?
Yeah, okay, hello.
I have a question.
Okay.
For on the fun with files.java, the one that from last class, when you go up, when you call the method, what is the difference between calling it with the FFWF dot that like on line 10? What's the difference between calling the method with and without the FWF dot portion?
Well, if I'm in a static method, is a static method associated with a particular object or with the entire class?
Yes.
What's that?
I guess with the whole class?
With the whole class, correct. So if this method is affiliated with the whole class and not with an individual object, I have to specify what particular object I'm talking about, don't I?
Mm-hmm.
Right. But if I'm in an object method, like save bytes here, which is not static, I know that some object, if it's running, there's already an object that this method is running for. For example, if I call fwf.savebytes, when I'm running the method at that point in time, it's running for fwf itself. So I don't need the object reference. And in fact, it would be wrong to include it. That's the difference. Okay, so back to, what was it, week 2, week 3, probably week 2. Yeah, object methods, you can't call an object method without already having the object reference in place for it, right? So again, if I'm going to call save bytes, I have to call it in reference to a particular object. So the Java already knows when the program is running, if save bytes is running, it's running for a particular object. So I don't need the reference for it. Likewise, when from that particular object, if I were to call, say, load bytes, right, if I did it here, it would carry forward that same way. It would say, FWF at this point is calling save bytes. Thus, if I call an object method, it's also for FWF at that point, right? But if there was some other object like FWF2 down the road, then this load bytes would be called for FWF2. If it were FWF2's save bytes. So the reason is that that's it. If it's a static method, then a static method is not associated with an individual object, and you need to specify which object you're running these object methods for. But if it is an object method, then that riddle is already going to be solved. Does that make sense?
Okay, yeah.
So that's the difference. Okay, good. Good to get these things out of the way. That's fine. All right, so fun with files 2. So we're going to do something pretty similar here. We're going to say, and then for, and then for this one, we're going to call again, it's save object, load object method. So let's create those first. So. Okay, now one thing I can do, I could set this up to save any kind of object I want. Okay, so I'm going to call this object O. And then this one, void load object. Doesn't need anything. And that is going to return an object. And for now, I'm just going to call that return null. We'll fix it out in a little bit. Okay, so this, I'm going to create a new object. I'm going to use one standard one. I'm going to use a string, and I'm also going to create my own separate one. So let's call it class FWF object. And it's just going to be an ordinary object. It'll have a couple of data things. Int x equals 0. Let's just give it an int x and y. And we'll give it a constructor FWF object int x. Okay. So we have a custom object we can do stuff with. So what I'm going to do first is I'm going to call save object and write that to a file. So we shall do our basic things. So first, file f equals new file, and let's call it objects.dat. Okay, and then we'll do our try catch. So we'll do try, and then catch, IO exception. We're going to need another exception in a minute. I can just actually lift that from Fun with Files. No need to reinvent the wheel here. Okay, so that's fine. So I'm going to try to build the water slide. Now the first thing we do with this, as before, we build up the file output stream. So file output stream FOS equals new file output stream, and we affiliate it with the file. Okay. So create file output stream and affiliate it with the file. Okay, second thing, we create an object output stream. So just like before, we're building the water slide. We have this file output stream that connects to the file. Anything we push into the file output stream is going to go to the file. Likewise, we're going to create an object output stream and affiliate it with the file output stream. So again, building the water slide. So object output stream OS new object output stream, and we affiliate it with there. Okay, easy. And at that point, we're done. We can close out the streams. So FOS.close and OOS.close. Great. Okay, and let's put in a confirmation message. So here we're going to try to save an object. We'll start off with a string. Okay, so string s equals a. Okay, and we're going to save it. We're just going to save it to save object, and we'll save it as an object. So we will do fwf2.save object. We're going to save s. Okay, and we can do this even though save object accepts. Right, it accepts a string, accepts an object. Well, all strings are objects, right? String is a subclass of object, so there's no problem. Everything that an object has, a string will also have. Okay, so that's it. Let's see how that works. So we'll bring up a couple things here. Let's see, go up to my desktop, pop up a little bit into the workspace. And we can verify that stuff gets saved in just a moment. Okay, so we'll run this. There we go. Object saved successfully. Let's look back in our window. And there it is. Objects.dat. Boom. Done. 4 bytes long, which makes sense. That's about how long the string is, right? The string is 3 characters and then an ending character, which we don't see. So great. That's done. Now, next thing we can do, we can load the object. Okay, so let's do that. And we're going to do this. We're going to say string t equals there. Okay, now what are we doing here? So first one, create a string, save it to a file. Okay, the second one, create a string by retrieving it from a file. Okay, now our load object method returns an object, but since we know that it was a string that got sent, we can safely do this. We can do this strange little thing. We can save it this way. Okay, so when we load that object, we know it's going to be a string. Let's see what happens. We will say, let's fill this. Okay, so once again, same thing, right? We're going to do file f is a new file, and we'll use our same file location, objects.dat. Okay, we're going to do a try catch. Lift these catches. Now, what we'll see in just a moment is that we're actually going to need one more catch, but we'll get to that in a second. So first, let's pull all this. Okay, so here it's going to be file input stream. You know what? I'm just going to do this. I'm going to so here we go, file input stream. Let's do that. Input. Okay, great. Input. Okay, so we have all these. Boom, we've created them. We're going to call it FIS just because, and OIS, and FIS, and we'll fix these things, and FIS, and OIS. Oh, system.out.println. I don't know what I'm doing there. Okay, so we're going to read stuff in. Okay, and how are we going to read it? Well, we need one more step, right? So we're not just writing it, we have to read it as well. So we're going to say object O equals OIS dot, and here we have our string read object. Okay. We need another exception type. This is our one. I just want to make sure that was the right thing. So catch class not found exception. And this one is the idea here, why we need this kind of checked exception. Imagine if we're reading an object from a file and we want to store it as that object, but we don't have that class definition available, right? So somebody else wrote some other class and we're trying to save it to our own. Well, yeah, we're not going to have that. That is a big problem. So we need to check that exception to make sure if the file contains a class that we don't have a definition for, it can fail gracefully. So we'll put in a little message there and we'll say, required class definition not found. Okay, that seems like a good error message. Okay, but what we're going to do, right, here, read the object from the file. So very simply, walking through all this stuff, first, we create the new file object. This is where we're going to read from. We do our try. This is the stuff we want to do. So we're going to build the water slide here, create the file input stream object, affiliate it with the file F, create the object input stream, and affiliate that with our file input stream. So that's the water slide we've built. Then once we have that, we can just pull the object. We can call our object input streams read object method, and that'll pull the next object from the file. We'll assign that to O, okay? And then I can just return O here at the end. Okay, so let's see what it doesn't like there. Oh yeah, because that was here, object O. So that's fine. So here, let's run it, okay? And then we can hopefully nothing falls off the rails with this. Let's see how it goes. It gave us a null one. What are we doing here? Did something go wrong? Something did go wrong. Oh, because I got to do string O. That's why. Sorry, I'm a little... All right, it's better to do it here. So I'm just going to have it, that'll work. Fine. Not sure what's going on here. Is it not saving it? This is really weird. Oh, hold on. Unspecified input output exception. Let's see. No exception. File input stream affiliated with S. Objects.dat, it's still there. Sorry, something's gone a little bit wrong. That's where it fails. This is strange. I'm not seeing what the, we're going to do a little bit of debugging here, I guess. Okay, so I'm going to save successfully. We get the object. Let's see. I'm sure that's loaded correctly. I think we're going to do a diagnostic test here. I'm going to mention something. System.out.println. We'll figure out exactly where it's failing, but I'm pretty sure it's failing right here. So we should see just a 1 when we run it. Boom, yeah. Okay, so it doesn't like that. OIS.readObject. That's strange. So not serializable? I know it should be. Sorry, I'm just thinking if there's, I'm just refreshing my memory if there's anything I missed. This is strange. Sorry. Oh, because I'm saving it as an object. No wonder. Yeah, okay. So I'll do that. String S. That's the problem. I was looking in the wrong place for the wrong thing. So let's say we're going to write this. Did I not write the object? No, I wrote the object. Maybe I didn't. Oh, shit. Did I just never have that? I think that's what it was. Oh, geez. Okay. sorry. This is how you can easily go wrong when you're looking for the thing. So actually write the object to the file. That's the step we missed. Okay, I was wondering why we were a little bit os.write. Okay, and we're going to write this object out. Why doesn't it like it? Method write int. Write object. There we go. Okay, so that should fix it. I'm gonna bring this stuff back to here. I wanted to do this generically. Let's see what happens. Okay. So object O. No, we'll say here O. Because we shouldn't have to convert it until we're actually ready to use it. Okay, and what's up here is a problem up here. Okay, we have to typecast it to a string. Okay, now let's see how this goes. Hey, that's good. There we go. Okay. So anyway, it's easy to make these little mistakes when you're putting stuff together, but here's what I want to show you. Okay, so in our reading, again, we create the water slide, we read the object. At this point, O is an object, right? Even though it was a string when we saved it, that's fine, it is a string, but since all strings are objects, we can use the object reference to refer to it. But Java still knows, hey, this thing that you're calling an object, it's actually a string. It's just we're referencing it through an object reference. So this is our introduction to polymorphism that we'll get next. Anyway, so when I call this method, load object, it returns an object, but I can typecast that object to a string because I know it's a string. So there's no problem. What else? Well, suppose, right? Suppose I want to save a different kind of object. Well, all right, I could do that. I could do something like, right, FWF object. Okay, so I'll do FWF object, FWF is a new FWF object, and I'll give it the values 1 and 2. Okay, so that's FWF O. That's fine. And I can write that. I can save that to file as well. FWF2.save object FWFO. Okay, and this is why I want to have these methods be generic. So with this one, I'm reading an object. I'm reading an object from the file. This method doesn't care what kind of object it is. So it could be a string, it could be an FWF object, could be anything I want. The point is, I'll retrieve it, right? And then I can save it first. And here again, I'm saving it as just an object. Then I can retrieve it as an object as well. It's a handy thing. So I don't have to write completely separate new code for this. I can still use these same methods. So I'm going to say here in this part, FWF object FWF1 equals, I'll call that method. So again, I'll typecast it to an FWF object, and I will call the method FWF2 load object. Okay, and then I can print out the contents. Sometimes it does that. Okay. So let's verify that this works. Ooh, doesn't like that. No, what am I doing? Something else. What's no? This is no? Oh, it's not serializable. Sorry. I have to use the serializable interface. Cast a string. Where's string? Or am I casting it to a string? Oh, it's doing it the other way. This is strange. All right, so things are a little bit of a problem here. I'm just going to do it with one. Let's save it this way. That should work. Usually you can do this correctly. All right, so we're going to save one. We're going to read it. See if anything goes wrong. There we go. That's a little strange. So was I sharing a reference? I hadn't tried to do this before. I mean, you can definitely save multiple things. Well, anyway, so that's a little bit of strangeness there. Certainly, I have done this in the past where I could save. It doesn't like that. Well, you're always learning. Things that used to work don't work. Yeah. It's not a string, though. I'm not trying to cast it to a string. Very strange. Huh. All right. Well, anyway, I'm going to leave that where it is. So this thing, if we wanted to save multiple objects, then certainly one thing that we could do is we could make a meta object. If we wanted to save everything, we could make an array, we could save something else. But let's make a mega object, class big object, which will contain, and we'll say implements serializable. You have to do that when you're saving data from objects. Okay, so I'm going to have this contain an FWF object, and I'm going to have it contain I'm going to have it contain a string s. And then in the constructor, big object is going to accept those things. We'll use our standard okay. So if I want to save these two objects together in one file, one option I can do is create a class that contains both of them. That's an easy way to do it because this thing here is strangely not working at the moment. So if I wanted to, okay, I can do this. Good. Let's bring it up here. So here I'm going to say create a string. This, and then I'm going to combine those all in a big object. So big object B equals new big object with the two things, with S and FWF 0, or FWF O. That's strange. I got to flip them around, my bad. All right, so we're running into a few speed bumps here. That's okay. Be done in a moment. Okay, so here, create string and FWF object, combine in a new class. Object, save the big object. Okay, so I can save that. I can save B to the file. And then, again, I can retrieve that. So I can say here, get rid of this, get rid of that. Okay, so this, let's say big object B2. Equal to a big object. Okay. Loading that. The string is b2.s, and the FWF1 is E2 dot. And it's just F, I believe. Yeah, dot X. And this is B2 dot F dot Y. Okay. Okay. So now let's see about this. Ta-da. Okay, so I'm able to do that by encapsulating them in both, but apparently there's some weirdness that the sequence of the object apparently is now for the entire file. That's strange. Okay. So anyway, you can do this. This objects thing is a very easy way to save particular objects. It's useful if you want to save an array or save a, a compound object, if you will, that one object that contains other objects. You can use it for that. It's pretty easy, straightforward to do. Yeah. Anyway, so there's that. What else? Oh yeah, so I wanted to go back, right? Saving and loading arrays happen the same way. So I'll just keep talking about that. If you want to save an array, you can do that. For example, I could do it, if I had wanted to do, instead of saving a big object as to the file, I could simply save an array to the file, right? So save an array to file. So I'll say int array numbers equals new and say 100, right? And then I could send that as a as an object. So I'd call FWF2.save object numbers. Okay. And likewise, I could load it same way. Load an array file. Same thing. Numbers 2 equals FWF2.load object. And I just need to typecast it here to an int array. Okay, and all this is perfectly fine too, but I get rid of this, I'll leave this back in. Okay, so this is something that you are going to end up using for your second application assignment. You'll be saving stuff to disk, and obviously you will be saving your employee data array. Okay. Questions on this? Does this all make sense? Anything unclear? So what are the key things we did? Well, I gave you this object saving class. Again, right, the water slide is object output stream or input stream. And if you want to write an object to the file, you can call write object. If you want to read it, you can do read object. There are some troubles that happen when you try to mix multiple classes in a file. It doesn't like that, but you can easily get around that if you need to by creating new classes that combine these elements. Or if you wanted to go the other way, you could create an array of type object and simply save that array. And again, we'll get into that with polymorphism next lecture. So, okay, last thing I guess I got to cover is this J-file chooser, right? So it used to be up here at the start, no longer is. It's at the end now. Okay, so there's a few file methods that are worthwhile to know. You can do, if you want to find out everything that's in a directory, you can call list. So first thing, a file object, number one, it can be a file, but number two, it can also be a directory or a folder. So there's that. And we'll see that when we get to recursion later. If we cover recursion, we should. Okay. There's an interesting thing with that. But here, for example, simple thing to display the contents of a directory. So create a file array, right? An array of strings that calls the list method, directory.list, right? Or file.list. That method returns an array of strings, which is all the contents of that directory. So another thing you can do is a JChooser object. So JChooser basically does a little pop-up window. So you call its open dialog, show open dialog method, send along null, just show it in all the default options. And you can do that. So for example, if I want to, pop-up window, let's show it. So I'm gonna show a file explorer pop-up. Okay, I gotta import that. Problem here. J-file chooser. Oh yeah, J-file chooser. That's the other ones. So it's in the swing components because it's a J-file chooser like a J-frame. It's that kind of thing. GUI. It's a GUI object. Okay, so we have this. We call it. I'll show you the thing. Boom, there's our little file. So it pops up in the documents directory for some reason. Wasn't expecting that, but here we are. Okay, and if I want to do something, I can select something and say open. If I don't want to do something, I can do cancel, whatever. Okay, and then I can close out the application. Okay, now that of course is not very interesting, but what I can do is I can pick things, right? So I can do this. I can say, status. So there's some constants associated with the J-file chooser. What I can do here, I'm just going to overwrite that. So I can set this status variable to be the result of this open dialog. So whenever anybody clicks, right, this method call will return a code depending on whether the user selected a file or not. Okay, if they did, oh good, I'm still sharing. If they did, then that's what I'll get, right? It'll say you clicked open, right? You selected a file or folder. Okay, let's go with a file. And otherwise, you canceled. You did not select a file. Okay, great. So that's easy. So we can run this. We get our little pop-up window at the end. So if I select something, there we go. I selected a file. Easy. And otherwise, I would get that I didn't. Now, what can I do with that? Well, of course, what you can do, this J-file chooser, you can get whatever the selected file is, right? So file selected file equals chooser.getSelectedFile. So you can do this. You selected a file, system.out.println J, or what is our chooser.getSelectedFile dot toString. We'll just do these. We don't want to actually do toString. We'll say get name. Okay, and if we wanted to, we'd get the complete path as well. So if you were running some application, you need to find what the file name is. You could also do get path, get absolute path. Boom. Okay, so we can run this. What's our error here? Something it doesn't like. We run it. Boom. So I pick something. Let's pick this one, some text file. Boom. You selected this file. I selected that, and here's the complete path to it. Okay. So that's it. That's J-file choosers. They're these little windows. Sometimes they can be useful if you want to write an application that, for example, you know, allows people to select files. Whatever you do with that file, then, for example, you could do something else. You could do put this very at the start, okay, and I could say, for example, save this, use this as the file. I could save some string to the particular file that I selected. All right. So, for example, I could say, I could send along the file with a method call. If I do save object from this, right, I could embed all of this here. Let's do it this way. I'll put it all up here. Okay, so what I'm going to do, I'm going to save this with file f equals chooser.getSelectedFile. Okay, easy. And so I'm going to print out the name and the path. And over here, I'm going to send that along with the save object method. So I'm going to save it to file f. And for this one, I'm going to read it from file f. So I'm going to update both of those. Here, it's going to be file f. Okay. And down here, it's also going to be file f. So I don't have it hard-coded in. I can actually pick the exact one I want to do. So for example, I could run it now. Okay, and I could scroll up, up, up. Let's see here. I want to go to desktop. And in desktop, I want to go, it's probably me. And it's a little strange going from the desktop. Where's my stuff? What I really want to do, go all the way up. This PC. Let's try it on this PC. Videos, pictures. I mean, there should be a private file for me. This is what is a little bit surprising. And I'm not even seeing that. It's like the desktop of the desktop. Oh, there it is. There's my word. I don't know why I didn't find that before. Okay, great. So there it is. I can save it to objects.dat, and now I'm selecting the file to save it to. Ta-da! And there it is, right? I selected that one. I saved stuff. Great. So this allows you to do dynamic file selection and then updating those files. Okay, well, I will post this code on Blackboard. And at the moment, I'm going to stop the recording.